Okay, PLC math instruction. Doesn't that sound like just way too much fun for words? By the time we get done, we should be able to program the add, subtract, multiply, and divide instructions. I'm gonna list the advanced math instructions that are available on 503, 504, 505, and micrologic sample. To perform mathematical computations. All kinds of cool math functions in there, in addition to add, subtract, multiply, and divide. You have the compute instruction, which is way more powerful on the 5000 platforms, compact and control logic controllers. Like you can do square root, logarithmic functions. There's all kinds of things you can do with math. The add instruction has 3 operands. 2 of them hold the source data, which are added together. Either both sources can be registers. One can be a register while the other is a number. And third is the destination where you want the result to go. It is possible to put the answer back into the same data register. So if you start with, say, N7:0, you add 1 to it, you stick it back in N7:0, and all you do is increment that by 1. In order to get the add instruction to work, has to see a logic transition from false to true. Been a long time since I've done this. If there is no conditional, gosh, it's been a long day already. If there's no conditional logic, and you say N70, add 1, put it back in N70, it'll do that every scan. So you're actually counting scans rather than just adding 1. As long as you're putting your result into a different data register, it still does it every scan, but it doesn't increment like that. So with your conditional logic, in that case, switch number, well, just switch. Every time you increment, it takes what is in N70, adds what is in N71, and puts the answer into N72. Status bits carry overflow with 0 and sign. If there is a carry generated, like if you add 5 plus 7, you get 2 with a carry of 1. So it'll throw the carry bit. Overflow happens whenever you try to, or when your result is a number that is bigger than will fit in a 16-bit register. Since these controllers are 16-bit, and bit number 15 is used for whether it's positive or negative, you can fit a maximum of 32,767 in the register. Anything bigger than that, you'll throw an overflow. Zero, of course, is set whenever the result is zero. And then the sign tells you whether it's a negative number or not. So it has bit number 15 in your register. Okay, that's a description of the status bits, and that is the status bit descriptions. How stupid is that? Is that not the same information? Two different slides. Okay, subtraction, same thing. Source A is what you're starting with. Source B is what you're subtracting from it. And then the result goes into the destination, got the same bits. So N70 minus N71 equals N72. Multiply, basically the same thing. Source A times source B equals destination. Of course, add instructions and multiply instructions. It doesn't matter which order the source A and source B are in. Subtract and divide absolutely does. 5 minus 3 is a completely different answer than 3 minus 5. Division and multiplication. This is really simple stuff. You guys know how to add, subtract, multiply, and divide, right? Those are the advanced functions. Arc, cosine, arcsine, sine, arctangent, blah, 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 blah. The compute, I said on there, pretty powerful, but on the 32-bit controllers, it's way more powerful. Be some really cool stuff with a compute instruction on a 5000 controller. There's a compute instruction in process. Tangent, whatever is an N71 multiplied by the cosine, or whatever is an N72, the destination is an N70. Given the following equation, you can use the compute instruction to solve it. So there, Y would be your destination. And then A times the natural log of B times E to the C plus tangent of D. It does follow order of operations too, by the way. So parentheses, exponents, multiply, divide, add, subtract, in that order. Yeah, very important. Note that integer registers such as N70 hold integer numbers, which means there is no fractional or decimal part. The answer, so if you come up with a number that has a decimal portion, it'll be truncated. It doesn't even round, it just cuts it off. Floating points, or real numbers, or numbers with decimals. I see you took my suggestion and you were safe.
Yes, sir.
Okay, x to the power of y. And there's your compute. Those two are actually working together, aren't they? F8:5 is the destination of X to the Y. And then it's part of the expression in compute instruction. Commonly used math instructions. Clear. That one, anytime you need to clear out a register for whatever reason, just clear at that address and it writes a 0 into it. You can also just move 0 into whatever register it is. It'll clear it out the same way. Double divide a 32-bit number by a 16-bit source. I've never personally used that. Decode 4 to 1 of 16. Also never used that. Negate, all that does is flip the sign. Positive becomes negative, negative becomes positive. TOD means convert to BCD. So, not sure how you get convert to BCD out of TOD, but I guess to BCD, to D. Sure. FRD from BCD to binary. Square root, copy data. Copy is used whenever you have data that you want to move from one register to another, but they're different types. If you're going to move from one bit file to another, you just move. If you're going to move from one integer file to another, you just move. If you're going to move from, say, an integer file into a floating point, you have to copy. Fill contents of source register or a constant value is copied into the destination in an ascending order until the value entered is the length. Try this again. Until the value entered in the length variable is 0. So if you say fill data N7:0 and you give it a length of 3, it copies into 0, 1, and 2 and then stops. And then SCL or scale data, that allows you to scale one range of numbers into another range of numbers. So if you have, say, a 4 to 20 milliamp analog signal coming from an input device, you need to scale that to 0 to 100% on the tank fill. That's what you would use. Much easier to use scale with parameters though, because you just tell it what the raw minimum and maximum input is, and then what the scale minimum and maximum are, and it does the math for you. Logic's Pro example we don't care about, and that is the last slide.